Well, hello everybody. Welcome to the webinar. As is extremely normal in these things, we're going to give everyone a few minutes after the official start date to time to join and grab their coffee or whatever, and we'll keep an eye on the participant numbers. And when they plateau off, we'll begin. But just give us a couple of minutes. Okay, so let's get started. Welcome to this webinar, whether you're watching live or on a later recording. We've got a catchy title called "Give Your Coding Agents the Security Tools They Deserve." Probably should have worked on a more exciting title, but there we are. I think it actually summarises what we're going to talk about. So first, I'll introduce myself, and then I'll hand over to my esteemed colleague Matt, who will introduce himself. My name's Robert Haynes. I am a marketing engineer. I'm probably heavier now on the marketing than I am on the engineer anymore. I did have a proper job a long time ago, but I've traded brain cells for crayons. So I'm going to do a quick presentation, and I'm going to hand over to Matt, who's going to actually show you how this all works, and I'll be asking some questions both on my behalf and on your behalf as we go through. Matt.
Yes. How y'all doing? My name is Matt Brown. I'm a solutions architect here at Endor Labs. Been here for almost 3 years now. Happy to chat with everybody today and show some cool stuff.
Excellent. So quick bit about this webinar. Obviously, we're going to be talking about AI coding agents, kind of the good, the bad, and the ugly. Going to talk about the Endor Labs AURI platform, or AURI, or however you like to pronounce it. We've had so many discussions about this. Going to talk about agent enhanced static analysis. So we'll talk about what's going on with our static analysis, because I mean, really, if we think about this, there's two parts to this webinar, or two themes. We want to give really good security tools to your agents that are writing code, and so you have to have both those things. So you have to have good tools, which I'll talk about a bit, and then you have to give them in a format that your agents can consume, which we'll talk about as well, and Matt will show you. Then we'll talk about connecting the Endor tools to the AI coding agents. We'll do a demo, and then we'll take some questions. There is, as you've probably seen if you've used any of these things before, a good Q&A system that you can use, but I'll talk about it now. Housekeeping. Recording will be available afterwards. You don't have to worry about noting anything down. This will be available possibly at the link you signed up to, but our producer Amy will handle that complicated business. Questions, use the Q&A feature. If you want to talk about if it's not working, you've got problems, or you want to make a comment that's not a question, or you want to talk about how wonderful we both look, then just use the chat feature. Random heckling is fine too. We like all that. Okay, so with that, let's start talking about the first part of this webinar. Okay, so what's the problem? Well, I mean, problems are maybe a strong term. AI agents can write insecure code at scale. So I'm sure we've all used AI coding agents. Even me, I've done some silly vibe coding for demo purposes, and it can churn out code that I could probably write with lots of tabs open and swearing in an afternoon in about a minute. So tremendously powerful tool to increase this one little chunk of the software development lifecycle, which is the actual coding part, which is good. But the trouble is they also replicate insecure patterns. So obviously they've been trained on open source. We grew our models by pointing them at huge open source repos, and that means they've trained on everything. So they replicate all the patterns they find, which is what we expect from an AI model. They don't know which packages are vulnerable when they see them in a manifest file, and they don't have that context. So obviously the result of that is you get vulnerability, supply chain risk, and blind spots. There's a stat here that says AI, only 10.5% of AI generated code is both correct and secure. Now, I'm personally a little bit anti this sort of fear mongering of AI code, because I've worked for loads of security companies, and I've been someone that was kind of not maybe writing proper code, but written scripts and stuff for system administration. And I've definitely made my fair share of screw ups on this thing. So my hot take on this is, yes, the stats look alarming, but remember, quite a lot of human generated code isn't so great either. Now, the Varun, who started and runs the company, took issue with this slide, and said that there's really good evidence that, based on PR analysis, that there's twice as many security findings in PRs generated by AI code as there is in humans. So I think that's kind of true. But I don't think it's quite as bad, maybe. Or I think actually we're overestimating how good a lot of coders are, because I've certainly made my fair share of mistakes as well. So you kind of like, it's true, but also it's also representative of where we are, where we were as an industry. So why aren't agents writing as secure code as we would like? Well, I mean, if you think about it, you don't you don't make an AI model, you kind of grow one, you kind of train it. So it's kind of a semi-organic purpose. So, you know, we're training it on lots of code. I don't think anyone's trained an AI on fully secure 100% bulletproof code as of yet, but who knows what's going to go on. The other thing is, because there's a long period, it takes a while to train a model. And obviously, the more complicated and bigger the models are, then they're taking longer to grow, but also we're throwing more compute power at them. So, but what happens is it's a kind of a point in time. So if you think about, if you follow any, like, if you ever look on OSV or any of the other places or you look on Endor Labs about the number of vulnerabilities we report, they're happening all the time, every day. There's like lots of problems every day reported all around the place, because there's an enormous amount of open source code. But if you're training on a point in time thing, and then CVEs come out after that point of time, then clearly you're going to have gaps in this space. So it's you can't really blame the creation model, because that's how it works. It may be, even if you told about every CVE when it was trained, then by the time you actually launch the thing on the market, there'd be dozens to hundreds of new ones. So it's kind of tricky. Um, so it is a problem. It's not, as of yet, an enormously solvable problem at the root. I do think that models are getting better. I don't know if you see that, Matt, but I've occasionally tried to get my coding assistant to make a real basic coding error, like do a SQL injection or something like that, and it's quite resistant to doing that nowadays. That the actual quality of the basic code writing seems to be getting better. Is that would you say that's your experience?
Yeah, like it'll get like the super simple, easy ones where it's like, okay, duh, clearly this is SQL injection. I'm not using prepared statements,
Hmm.
whatever, right? Like,
Yeah.
you know, cyber defense 101 stuff. It's the more complicated things that, I think eventually, some, years from now, hopefully we're both retired, that, eventually it'll be perfect. The biggest problem is, like, this slide explains it perfectly. These models aren't trained to, like, today. You
Hmm.
know what I mean? They're trained till a certain date, but guess what keeps happening? New CVs come out all the time, every hour, every day, right? And the other big problem is that, what are all these models trained on? They're all trained on open source. What does open
Yeah.
source have? Vulnerabilities in it.
Hmm.
That's another huge problem. Another one that I don't like, shame on me for not talking about it enough, but like, the context windows of these can only ingest so much. So let's say you have like a huge monorepo, right? Or let's just say you have a big application, or even, like, let's say, well, I'm working on a part of my application, but I sanitize everything properly in a completely different repo in GitHub. Like, there's a lot that has to kind of like come together and take into consideration, that it will trip up on these more complicated things. And not for nothing, you're gonna be digging into your pockets for money for tokens every 10 minutes to
Yes.
pay for this damn thing.
I saw a post on Reddit just about that today, where someone was using, and I won't name the service. Someone was using a newly launched, like, PR review service, but it was going to cost them $10 to $15 of tokens per PR review.
Oh my God.
That doesn't
Yeah.
seem. I mean, I know they've got some big data centers to build and lots of expensive, like, GPUs to pay for, but even then, that's like, oof, that's quite expensive.
Jeez, good Lord. I know, but now, like, every developer does a certain amount of PRs, and
Hmm.
and not only developer, the agents do PRs.
Yeah,
Not only
I mean,
that,
that's the thing.
the non developer folks are doing PRs. Like we have one customer said, like, of course I'm worried about what the developers are doing and the PRs they're opening. Of course I'm worried about what the agents are opening. I'm more worried about what the actuaries are
Yeah.
opening. They're not developers, but boy howdy do they love Cursor. And they love using it to do their little data analysis and to open up these PRs that I have no idea what they're in. So it's like, yeah, it's developers just are opening up more pull requests.
Yeah.
Agents are opening up more pull requests. People who don't code are opening up pull requests. So it's like you're kind of getting hit in all directions.
Yeah, it's I mean it is an exciting time. I think like obviously the temptation in security is to be the doom monger and sort of talk about
Mm-hmm.
the problems. But I mean it is fascinating to be here right now. It's kind of having
Yeah.
been through a few of these revolutions. This is the one that's you know as exciting as when you could first spin up a server for with a credit
Mm-hmm.
card rather than waiting for the guy in the data center to go and put a Sun server on a rack for you. I mean, this is
Mm-hmm.
really is quite a big change that we're seeing. It's quite exciting in its own way. Okay, so we've done all the kind of like these are the problems. We know that we've got like lots of people writing code, not who aren't necessarily developers. We've got models that are trained at a point in time and replicate the mistakes they've been trained on, and don't know about the new stuff. And we're churning out more and more code. We're expecting more code, whether or not that's just a. And if we're gonna stop that being a problem, and it's also we don't have bottlenecks elsewhere, we need to do some other things. So
Mm-hmm.
now we get to the solutiony part of it. So we recently launched or rebranded our platform to give it a nice friendly name called AURI. Um, it is it is a slightly different architecture to what most security tools have used before. Um, because and I think it's actually a really smart way of doing it. Because I mean, there's a temptation just to throw everything at AI. Like we're just going
Yeah.
to do everything. So we're just going to dump all the tools we've ever had, but we're going to throw everything at an AI agent and let it just sort all this stuff out. But that potentially replicates those same problems, and it's wildly inefficient as well. So the idea is that we're combining this agentic reasoning with the deterministic contextual analysis. That's a kind of a long-winded, slightly academic sounding sentence. But what it really means is all the kind of tools that Endor and other people like us, have built things like, really good semantic analysis of code. We have, in Endor, we build core graphs and, we trace the data from source to sink so we can accurately depict exactly what's going on inside a software, which we initially used just for our SCA tools to see if you were using a vulnerable function. But we've built all these things in fairly efficient coding methodologies. I don't even know what languages we use because that's not my problem. But we've used like C and C++ or Rust or whatever to build this
Mm-hmm.
fairly efficient way of producing a set of like useful data that we used to just use again kind of deterministic models to present that back as a list of findings. But what we're doing in AURI is that we're giving those tools, we're putting those tools on a shelf, and then we've got like a configurable like agentic tool chain that can take that information and do good things with it. And we'll get into a little more an example of this when I talk about the SaaS stuff in a minute. But it's kind of like the idea that we're getting the AI agents to write the good code. When we get into code review, the PR piece, we're
Mm-hmm.
widening out that context because when you're writing the code, the tools are just looking at the code you're writing within the context of that either that file or that project. But code review is looking not just at what you've written, but maybe why you've written it and if that's a good idea at all. And also, we don't want to fix stuff. We maybe when we're doing demos, we're going to say, "Oh, scan my code, write my code, scan my code, fix my code." But actually, the real solution is that you just include all of this in an instruction so that it spits back to you code that's being clean. But if to do that, you've got to hand back good remediation information to either the person or the robot that's writing the code. So there's kind of three things about we help write good code. We use a very wide context analysis when we're doing like PR type stuff, and then we hand back good remediation. I've got a slightly more complicated slide after this, which is it's a bit of an eye chart, but I wanted to just real quick to talk about how this works, and we'll just worry about this bit in the middle for this purpose of this. So if you think about this, There are three things that we have. We have like a basic set of information that's, I mean, static's the wrong word, but it's like it's common across all of these things. It's not
Mhm.
specific to the piece of code you're looking at. We have a really good malware feed, which combines both our own analysis and obviously we get a couple of commercial feeds in as well. But we're using a really clever, actually agentically powered malware analysis engine now. We know the vulnerabilities that we both get from those sources that we then enhance from by adding additional metadata around them. And then we've got things like call graphs. So we already pre-compute a bunch of call graphs for common packages. We have built this clever embedding engine for spotting snippets of code and stuff like that. And obviously the rules that you might apply to a SaaS tool, because the easiest way to find or the most efficient way to find a SQL injection or other thing is a rule-based solution at the moment. And then, this middle piece is like where we take some of this and we take your code. So we take the source code, we take the known set of like static data, if you like, and then we start looking at how we break this code up and do function analysis on that code. We build data flows and call graphs and spot things that are problematic. And then this is where the agent workspace comes in. So we look at, okay, so we've got all these indications. So before it would just be just a rule, but here we've got all these indications. Is this actually do we want to surface this as a detection? And then it's like, we're going to triage it. We're going to work out, okay, is this really a true positive? Is this a false positive? Can I try and exploit this? Can I use my agentic wisdom, if that's a good word? Probably not, but my agentic skills to see if this actually works, if this is really and we might hand back both of the things, but we'll say, well, these are the findings, but we think this one, our agent thinks this is a false positive or this is a true positive, and tell you why, or tell your robot friend why. And can it be exploited? And then how do we remediate it? And so here we have this really kind of like efficient pyramid. I always think of like, actually it's an inverse pyramid, because down here, this is per customer. This is low effort because it's common. This is the stuff that we use fast, efficient, functional code to on a per customer basis. And then up here, where we need to do the really clever stuff, this is where we're using the agentic stuff. And the
Yeah.
results, if we look over here, are we fix it faster, we find a lot fewer. We have a lot fewer alerts, and they're all good and not false positives.
A lot of good results. Here, I want to say a few things about this,
Go on then.
about AURI, about this slide. So, what was the kind of one liner somebody asked me if you could describe AURI? AURI is the mechanism that brings secure application security determinism to non-deterministic AI tools across the AI SDLC. And this is the thing, right? Like, let's take SAST and SC, all of our offerings together, right? You
Mm-hmm.
see companies say, okay, I'm going to use the pencil here. They say, all right, um, we use AI in our SAST tool. And what that means is you're just putting on an LLM to maybe
Mm-hmm.
you do some good prompting stuff, and it's not just fix the issues, right? And when you just have this, it's still non-deterministic. You run into the same problems. The context window is too large for LLMs to ingest. There's just a lot of things that happen here, right? So this, like, anybody can say, "Oh, I'm going to put LLMs in a SaaS tool." This is like what Claude Security Review is, and like Codex Security. It's just an LLM looking at code, right?
Yeah.
That's not enough. And these bottom two sections here, use the pencil again. This is what is the key differentiator with Endor, these things. Because
Mm-hmm.
for before all these LLMs took off, right? Endor
Yeah.
had call graph analysis. Endor had all these different kinds of technologies to do it the old fashioned way, quote unquote, right? The hard way of doing it by providing still really good results with like call graphs, with doing code segmentation, function segments, data flow analysis, like just doing all that. We've had that technology for a while. We have newer technology too, but we've had this technology for a while. This is what we're layering with the agents and with these agentic tools and doing all these agents. This is what brings the determinism to non-deterministic
Mm-hmm.
AI SaaS and AI SCA, however you want to describe it. This is the real kind of key differentiator. All this data that we have from all these different open source dependencies, all these different call graphs that we've built for years, this has really allowed us, and all the technology that we built, this has allowed us to really bring superpowers to these agents and to
Mhm.
actually bring you determinism to non-deterministic tools and LLMs and stuff like that.
Yeah.
So when people say like, well, let me see AURI. AURI is the mechanism with which Endor can provide every single one of these AI tools and provide this common language throughout the entirety of the SDLC and bring determinism to this non-deterministic kind of way of doing things with LLMs.
Yeah. And to a very large extent, from a as a customer, I'm kind of made. If I back in my days when I was buying things and was a customer of this kind of stuff,
Yeah.
I care most about the things outside the Ori box. Now, the Ori box is like how we deliver the results, and I think it's interesting, and I think it's a really good use. But from a if you're listening to this, the most important thing to you is that is probably the results over here. So actually probably a good time to flip to the next slide, because when we've tested this, um, we've tested it ourselves, and we've tested it with some of our sort of beta customers. We are seeing a lot fewer false positives.
Mm.
Now, I was having this discussion last week with somebody at our booth at a show, and I was wondering aloud, when it was developers getting all these false positives back, and they were getting annoyed about it, and quite rightly taking up time, and everyone hates to get like a list of things that are problems that turn out not to be. That's super frustrating. Now it's going back to robots, that and I'm watching cat videos or drinking my coffee while the robots are doing all this stuff. Does it matter? And then I thought, well, actually, as I found out this week, like you can burn through tokens fairly fast doing things. You can be hitting limits quicker than you expect, especially if you're using some of the more complex models. And so, actually, handing back false positives to your agent to fix is maybe not doesn't take you any time and cause you any personal problems, but it's going to burn through your tokens, which you could be using for writing nice, cool code. So, and that's going to have costs, and it's unpredictable because you don't know how it's going to use all this sort of stuff. So, I think it's actually quite important still. There's problems like coverage limitations. There's always things that rules won't catch. You do need some additional look at this. Business logic is hard to spot. I know when we were prepping for this webinar, and you were showing me some of the things you were going to show people, some of the cool business logic catches were like things that you were never going to see a SAST yet, because they just don't get that logic, they don't get that context. So I think that's kind of it is important to do this. I do think it makes a lot of sense. And the results, like we are seeing, like we've had people testing this out. We're seeing smaller number of tickets, which is what we all want. We want less tickets. We want less PRs, and because we're handing back good information to people or agents, we're seeing faster fixing. So, and we've got these customers down here, some of which I think have tested some of our early versions of the AI SaaS, but this is now becoming pretty much mainstream for everyone, and it's a really impressive set of results. So let's oh,
Hang on, go
sorry.
back to that real quick
Right.
because I want to say one thing.
Sure.
This 10x fewer security tickets. One of the customers on here that we have, I don't think I can say who, so I won't. One of the customers on here, they went from sending their developers security related Jira tickets. It was 2,600 a month, somewhere around there, to 140 after getting Endor. And if
Yeah.
anybody says, oh, well, you got to be developer friendly and you got to do this and shift up, you want to know what the most developer friendly thing is? It's that. It's less
Yeah.
security Jira tickets to them.
Hmm.
That is the most developer friendly thing. And yeah, of course, you make it friendlier in the ID and everything like that. And that's all fine. But like now they're like, okay, now we can actually build cool stuff and work on new
Yeah.
features and beating competition
And they
in
can
general.
probably fix things as well, because
Yeah.
if I send you 1,000 requests to go give demos to customers, or write me some stuff, or review my white paper or that I've written, or
Yeah.
come on a webinar, you just won't be able to do any of them. You'll do none. But I know if I send you two, then there's a decent chance you'll be able to fit my request into your busy life. And so it's just so much more efficient, because you're not spending time. No one's if you can't do everything, then you have to waste your own time sifting through what the things that have come in to work out what
Yeah.
you need to do, which is a huge pain in the backside. So let's just
I'll
do.
always help you, Robert. I'll
Oh
always
yeah, that, yeah.
you
Dangerous
know
words,
that.
Matthew. Dangerous words. Okay, so this is kind of how it used to work, and this is pretty much how everyone used to work. You can substitute everyone's like proprietary thing in the middle here. You know, this that sort of detect phase. Checkmarks have their own, Veracode have their own. Everyone does it in their own individual way. Um, like that, you can make arguments for which one was best and which one wasn't. But everyone just basically applied some fancy rule set and some fancy like processing and pre-processing on the source code to make results. And that's what you got. And you know, you have to do, even with the best tools out there, you'd have to do quite a lot of tuning. And you'd still get false positives, and you'd have a lot of open flaws. One of the customers I worked with at a uh, previous security vendor, and they were a big company. So that's not, I'm not like, this sounds like a lot, but they were a huge organization. But they had 300,000 open vulnerabilities in their instance, in their tenant of tickets to fix. And some of that was dev and test, and not all of it was production. A lot of it was like lower grade. But that's an unmanageable amount. And so if you have this, then you're going to spend an awful lot of time tuning this middle part. This is the bit that you're going to have to spend time on, and to just try and reduce that number of notifications. And that's pretty much how the industry worked until we started being able to throw in things like this triage agent. So this is an agent. It's probably actually a collection of agents. I have probably tried to delve down into the real guts of this and probably hit my limits of understanding quite quickly. So we'll just put it in a nice big box that says triage agent. And so what that happens now is we have a detection, we get some rules in, and the triage agent in its early phases was able to go, okay, let me actually look at these findings. Let me go back, look at the code. I'm acting as a security expert. I'm going to take every one of these findings, look at it, decide if it's a false positive and if it's a true positive, hand that back with my reasoning. So you might not get you might get a small reduction in the number of findings, but you don't get that many. Now, this is where it gets really exciting, because now we can run a sort of a twin path system here, where we've got this kind of like this rule set, which I think is still going to be,
Yeah.
until things are going to, still going to be the most efficient way to find a lot of stuff. You know, obviously, the nice thing for a customer using us is that you pay us per seat, and if we come up with a really good detection agent type thing, or a really good process in here, and if it costs us like a gazillion tokens, that's an us problem and not a you problem, because we have to work out how to do this the most efficiently and within the kind of making it that we can make a small amount of money by selling you things. So over here we can run detection agent, which is going to find other things and possibly the same things as the rule-based thing. We can still triage the open source findings, but the detection agent is doing its own kind of triage, and then we can deduplicate, and then we can pass it through an ability to, at the moment, just hand back useful information to the fixing agent, whether that's a human or a robot. So if you start doing this, if you compare this to where we were like 2 slides ago, A, it's more complicated, but B, again, the number of findings coming back and the quality of information in those findings is quite dramatically improved. We've certainly seen some really quite stunning results of this. And it's to a large extent invisible. You can essentially opt out of it if you don't want to do any of the AI stuff. But from a customer perspective, I used to do whatever command I used to do my scan, I do the same command to use the scan, and I just get better results. So it's no change in process. It just gives you better results with more contextual information when it gets handed back.
Yeah.
Um, so we've seen a lot. We've done some of our own testing on this. Um, we're seeing our false positive, true positive noise reduction down. Some of these numbers. These are all the things that have been found by a rule-based system, and this is what actually we thought they were as a true positive. There is a blog on this. I don't think it's actually this one. While Matt's doing the demo, I will throw into the chat, if I can find it, the most recent blog that Peyton wrote, and he explained, it was really good because it was a really beautiful step-by-step thing. It explained how we'd used our own SAST tools to find some problems in OpenClaw. And I think it's like the last. I think we found no, or maybe it was this one actually. But I'll throw the link in because you can. It's really easy to read. It's a really nice story about how we did it, and it illustrates the power of the AI process as well. So what we have now by using the AURI platform, by using a really good hybrid mix of deterministic tools that are efficient and fast, and the kind of like the agentic based stuff that's clever and flexible to give really good set of results based on solid information. Fine, that's all well and good. The next question is, well, that's great, but do I have to go and look on a web screen to see the results? And how do I get that information back into my tools? So just a final piece here on the final slide. We will get to a demo. Someone's just asked. Yes, there will be a demo. I promise. I will stop talking eventually. But over here I've got my agentic tools, and then basically at the moment this represents the kind of state of the art of how we connect all these kind of cool security tools over here with our AI coding agents over here. And we're talking about skills and hooks and MCP, but I think it's probably fair to say that this represents the situation this week, or maybe this month, or maybe this, if we're really optimistic, maybe this quarter. But I mean, MCP was all the rage because it was the only way to do things for a little while. Then we've kind of like hooks and skills have come up quite a lot. The pace of development means that it could be anything next. Who knows? Okay, so now, oh, sorry, it swipes too quickly. Look at that. I've been using the swipey bit on my mouse and it's not working very well. I'm not skilled enough with my finger to control. This is the good bit. I'm going to hand over to Matt, and Matt is going to give you the demo that you have been asking for, and we will then pause after that and take questions. I will ask some clarifying questions as we go through because I am hard of understanding sometimes. But Matt, take it from here.
No, it's fine. All right.
I'll need to stop sharing, and you will need to start, won't I? After you stop, you get a full face of you.
Ah. Okay, cool. Thank you. Okay, so we'll start at how we're like those skills, hooks, and MCP, and how we're integrating into something like the IDE or Cloud Code or something like that. We're also going to look at how agents work with the AURI platform, meaning, okay, what can something like I have Devin set up, Devin AI, if anybody's heard of that. Pick your poison, right? Pick your agent. They all work the same. Honestly, that's the thing I like about these kinds of mechanisms is like, doesn't matter if it's Cloud Code, if it's Cursor, if it's Devin, if it's Factory, if it's Open Hands, if it's whatever, it doesn't matter because they're all agnostic and we can talk to them all and they can all communicate with us as well. So we'll look into that a little bit and then we'll look at some of the new SaaS stuff as well. And please do feel free to ask questions along the way. Happy to answer anything there. So I have Cloud Code set up here and we have a set of skills that you can really do anything you can do with Endor CTL, which is our CLI tool. And this is something I'm very grateful for at this company is that we are API first, meaning anything we build, literally anything we build it for the API or CLI first, then it makes its way to the UI, right? We're not focusing on the UI first. We're focusing on building the technology and building the CLI and API first. And that's really been beneficial for these agents and for these tools because that's how they get all the data. That's how they're able to actually get all the data and communicate with it. So we have these set of skills that anything you want to do with the platform, you can do via the skill or an MCP and implement that with the hook and kind of direct the LLM with these hooks, right? So setting it up, getting some help, doing a scan, a full scan. Hey, I just want to do SCA. I want to do SaaS secrets, container scanning. I want to check for a certain vulnerability. I want to view our Endor health scores. I want to go ahead and view our upgrade impact analysis. That is, we're taking the call graphs that we generate and kind of simulating an upgrade. Well, they're on this version now. They're using these methods and functions. If they go to this next version, it'll fix these vulnerabilities, but it won't break any code because we have the call graph analysis. We can actually see what methods or functions that they're using, and if any of them have been changed or something's been removed or something like that, that would cause a breaking change, right? So you see, there's a lot that you can do here. And I have some stuff pre-set up here because I didn't want to wait for the LLM to respond and do all that fun stuff, right? So, hey, let's use Endor Scan to run a quick project, right? Or a quick scan on this project. Very quick scan, took about a minute, where we say, all right, show me the findings. This is kind of basic SCA. Hey, go ahead, basic SAST, go ahead, do a scan, right? And then it gives us some recommendations. Oh, use Endor Fix to fix this vulnerability. Run a full scan with reachability. So I said, all right, let's run a full scan, right? Now this will give us the reachability. This gives us the call graphs. This gives us all that really valuable information. And it spits back out, all right, hey, these are the ones you got to fix now, reachable dependency and reachable function. Now, again, Claude Code is not doing this analysis. I'm in Claude Code working with my project. I want to run a scan before I check stuff in or as I'm coding, whatever have you, before I go to commit something and open up a pull request, right? This is secure by design is what this is, or secure by code, however you want to call it. This is I'm actively addressing these issues now while I'm working on the project rather than um, later on down the SDLC, right? So it's pretty nice. It'll kind of put everything out for us. And again, what's good about these skills is these are the ones that we've written. Obviously, we know Endor and know Endor CTL the most because we're here. And these skills, I said, when I was writing these skills, I'm like, okay, let's account for this. Let's try to format the output like this or that. The really cool thing about these skills is you can use ours as like a baseline, and then you can tweak it to configure it how you want to and how your organization handles it, right? If you do things a certain way, it's very open to say, okay, I want to present results like this, and then I want to be able to have the agent open a pull request in this type of format in a pull, to have it more easily addressable for the developer, whatever have you, right? It's completely customizable, which is really nice. We just have a bunch out of the box that you can go ahead and use. But again, this is completely up to you. So we'll lay all this out. And then this is where things get interesting, where we say, all right, help me figure out what I can fix without breaking any code with our upgrade impact analysis, right? So we have that data. The LLM goes ahead, grabs that from our API, from a scanned project. We come back, we say, hey, look, if you go from this version to this version, 2.1.13 release to 2.7.18 for Spring Boot Starter Web, you'll fix 74 issues. You'll get 4, but the risk is low and it's going to break your code, and they're low risk remediations and they're low vulnerabilities, right? This one, again, risk is high. Is it safe to apply? No, there are breaking changes, right? For example. So there's a couple things you could do. There's a patch. We have patches available. Or another thing that you could do that I've been messing around with and playing with, and it'll say like, hey, is it safe to apply? Do you want me to go ahead and address these? Blah, blah, blah. Right? So then I said, you know what? Let's use both. Using the call graph context from Endor Labs for the breaking changes, can you help me fix the vulnerabilities that are a high risk of a breaking change, but implementing non-breaking changes to the project code? So essentially, I want you to upgrade the component that is a breaking change, but fix the stuff that does cause it to break without my code breaking, so that I can upgrade and fix these without implementing a breaking code. So you're taking our context for all the call graphs. You kind of see where I'm going with this.
Mm-hmm.
The LLM is not going to be spending buttloads of tokens and emptying your pockets and taking so much time trying to figure out all those breaking changes and building a call graph and building this Maven application and so on and so forth. We have the data. Here you go. Here's our data that you can use, kind of thing, right? So it goes through and it says, all right, Endor, you're telling me that this is a breaking change. in this Java method here, it went changed from public to protected in that version of Jackson data bind. The reachable call path, this is our data that we're given to the LLM. And then the LLM is going to fix the project code inside of this application to say, okay, let me go ahead and do that. And then let me go ahead and update the POM. And I'm going to go ahead and also do the Spring Boot parent as well to then say, all right, I've gone ahead and I fixed not only the ones that Endor just told me a simple upgrade and is not a breaking change, but also the ones that Endor did tell me, hey, if you upgrade, this is a breaking change, but here's what the breaking changes are. Thanks, Endor. I'll just do it now. And I know what to do and how to actually implement it and fix it. And then both upgrades have zero known vulnerabilities and zero compile errors. So I've gone ahead in, what was it, 2 minutes, 3 minutes? I've gone ahead and I fixed, let me see here, 74 plus 40. I'm not even going to bother with the math. 114 issues, a lot of them critical, a lot of them reachable. Obviously, standard SCA can't tell you if they've been fixed or if this will cause a breaking change or not. You get the idea. I just fixed a ton of really bad issues in 5 minutes in my ID or in my Cloud Code CLI before I've checked anything in, before I've committed anything. And now, not only does security not have to deal with this when I go and the scanner runs and then it spits back issues and does a pull, I don't have to deal with it. That's the other thing. I don't have to deal with this stuff now as a developer. So you can kind of see
Yeah, because I mean, none of this stuff is it's toil, it's grind, it's toil, it's not exciting, it's not contributing. I mean, obviously, security is everyone's job, yada yada yada, but it's not getting your sprint done, is it? It's not going to help you in tomorrow's stand up. If you say, well, I spent 3 hours trying to work out how to upgrade a package because it had it had a vulnerability, but had breaking changes in my code, and it's risk, it's pain, and now those you can get to that backlog of actual features or whatever you've got to fix, or actual user affecting bugs or whatever is out there that's actually impactful, and this is just kind of done for you. And actually, I think as you as we go back to this and we start using the kind of prompts in the creation of the code, that those it won't even create this stuff. I mean, this is great for looking at so we've got existing problems, but hopefully as time goes by, that anything net new that comes out of my developers environment is probably going to still have some things found downstream, but it's going to be a lot cleaner than what probably goes in right now.
Yeah, and that's what's so important about the data that we're going to be able to provide and all this stuff, because it's like, yeah, you want an LLM to do this, right? It's got to go and figure out all that stuff. It's trained on the open source stuff. Like, again, just the token usage. I've seen insane token usage, like absolutely insane. Like, we're talking tens of millions of dollars on a single project is what one customer tried to do. They said, yeah, you know what? We're going to try to have AI do this for us. I said, okay, let us know how it goes. That's what I said in my brain anyway. And came back like 3 months later, like, there's no way. They'll go people will go bankrupt doing this stuff. Now in 20 years, when GPUs cost $5 for 300 gigs of VRAM, then we'll have a different conversation. But right now, anybody who is also building PCs and is seeing the RAM crisis, that ain't happening anytime soon. If you're trying to build a PC, I'm sorry, just go with DDR4 RAM and hopefully it's better. Or Facebook Marketplace apparently has really good stuff. Anyway,
I'm not sure that our enterprise security architects would be encouraging of people to shop from Facebook Marketplace.
No, personal stuff, not work stuff. If you're building your own rig, then go do that. But anyway, so this is a good example, like within Cloud Code. But again, another example. This is in Cursor, right? I tell Cursor, hey, build a to-do list app, right? You kind of notice here, I didn't ask scan my code, make sure it's secure. Because, like, let's be honest here, how many developers are doing that? I think I can count on one hand. I mean, there are a lot of folks that really do care really deeply about security and are developers, and I admire those folks. Like those are when I was a dev, I did not do that,
Yeah.
shamefully. So you can kind of see here. Hey, build me a to-do list app. Help me write a function that adds the ability for a user to upload an image to this reminder. Right? I'm working in Cursor. I'm working with the LLM to write my code. Right? I'm not writing it all myself. So what does it do? It goes and says, "All right, blah blah blah. I'm going to go ahead and do that. Oh, let me add these components here. Those seem good. Those are vulnerable. So, or this one is vulnerable. So went ahead and added this component. Part of our rule set is we say, via MCP, and again, you can tweak these however you want, but like this is just an example to say, okay, let's say SCA. Anytime there's a change that's made in one of these files, I want you to do this. I want you to do this LLM, right? So went ahead, we made a requirements.txt. We had the version it was added. It's a vulnerable version. Endor, scan, tell me what you got. Hey, oops, I found I accidentally added a component with vulnerabilities in it. And this isn't like an old, this is Sonnet like 4.5. This isn't a super old model or anything like that. And it added dependencies with known vulnerabilities in it. And this proves the point of an LLM can add vulnerable code, no, anytime kind of thing. So you still got to do your SCA, you still got to have that data, you still have to have that context. Treat it like all these other tools where it's an assistant helping you throughout as you're building these applications here, you know. um and this kind of like last method of, okay, how do we work with agents, what's AURI doing, to actually bring determinism to all of this, this is Devin. So within Devin, I say, hey, I have this little weather application, help me write the ability to add a chatbot within the weather app. So, like, you can say, oh, how's the weather going to be next Thursday? Right? Silly little thing. So Devin went ahead and did it, right? It just goes ahead and says, yes, absolutely. What a great idea. Happy to help, blah, blah, blah. So it opens up this pull request that adds uh, OpenAI GPT 3.5. I don't know why I picked 3.5, but it did. So it said, okay, great, thanks. What we'll do as part of reviewing these pull requests, because these pull requests are now becoming like alerts, they're very noisy. And as an organization or security team, the ratio is like what? For every 300 devs, there's one AppSec person. Like that's maybe a little bit better now, but the last stat I remember, that's what it was.
That's when none of us have got any hair.
Yeah, like that, like, dude, nobody's gonna be able to review all those pull requests. Like, there's just no way. Stuff's gonna slip through the cracks. And again, you have developers just opening up more pull requests. You have agents opening up more pull requests in general and more pull requests. And actuaries and marketing people like Amy is opening up pull requests. I'm gonna call it Amy. And so we're gonna actually look at all those pull requests and we're going to compare it to a set of rules that we have. And we have these three agents that all kind of communicate with each other and look at these things. Developer, security architect, and DevOps agent, if I'm not mistaken. And these are going to look for things that, yeah, of course, CWEs, right? Like this falls under our SAST offering. We're getting into our SAST now. But they're architectural risks, business logic risks. Like this pull request that Devin opened introduced prompt injection. No big deal. Like again, it just did it. It did it for me. I asked it to add a chatbot in it, and it went ahead and did it. But it introduced pull requests. There's sensitive AI API keys stored and configured directly. We're changing the way we're doing PII data. We're handling PII data. These are things that you cannot like look at all these pull requests, and you should see some of these pull requests. They're like 2,000 lines long and 2,000 different changes. What are you supposed to do? Right? It's just not going to work. So what we want to do is look at these pull requests and have these agents work with each other to figure out, is this an architectural risk to this project, to this business? And sure enough, it will surface things out and will catch these certain things to say, hey, out of all these different pull requests, this one you need to take a look at, kind of thing.
So, I mean, so now me as the human component reviewing this pull request, which probably still should have, at
Mhm.
least I've got the work to, and I could probably take this and paste it into my chatbot and go, okay, tell me what these changes are.
Yeah,
But this is so much. It's kind of in the process. It's security specific,
exactly.
telling me exactly what's happened, and I can see, I can. My robot friend has told me
Yep,
what to look at, and I can then go back and to there, and then we can still
exactly.
scan it with the failing checks for the scans.
Exactly. That's exactly it. So like obviously we don't want to break a build. Like the last thing we want to do is break a build. We only want to break it if it's like, dude, you're
Yeah,
introducing prompt injection, like one of the worst things with all this new AI stuff, right? This is a really not great thing. So you set up these policies to say, like, listen, you just do it on critical ones, you could do it on high ones, on certain
yeah,
findings you could do it for. So that way these get caught before they actually reach out into
yeah.
problem and everything like
But
that.
you're in charge of what
Yeah,
policy breaks the build, and you
exactly.
can you can decide what's the risk profile and appetite for your business.
Exactly.
Um,
Like
yeah.
an LM opening up a pull request with these things in it, and then you merge. Could you imagine this kind of stuff? So
Mhm.
again, this is like these aren't necessarily like, yeah, they're CWEs. They could be CVs. They're more architectural risk
Yeah,
that we're
uh,
looking at that traditional SaaS just does not usually pick up.
yeah.
Right.
But these are the tools we're going to need because we were talking about a community sponsored, or we're just sponsoring some community discussion through
Hmm.
this cyber warriors. It's a really cool open source and community event that we're just helping to pay for the drinks or whatever. But there was as part of that, as part of the thing, we do get to talk about, hey, what would what do you think is a great topic for discussion? Obviously, we want it to be something that's going to get people interested and
Hmm.
excited. I do think there's that sort of, in all of our knowledge, we know that you tend to just shift bottlenecks around. So, if I make it so that I've accelerated 10x my ability to create code and create PRs, but I then don't have anything that accelerates the review cycle,
Hmm.
and don't have anything that helps the people that are supposed to be looking at the PRs. Either there'll be a bottleneck, or they'll just go, yeah, that's probably all right. The AI did it. It's bound to be fine, and then we'll see all these
Yeah.
things come through.
Yeah. Oh, looks good.
Yeah,
The
well,
AI did
if
like,
you've got a bunch of these stacked up, then
yeah.
what are you going to do? I can
They're
see.
just like they're like the funniest stories on like Twitter and stuff of like, somebody saying, guys, people are creating API keys against my account now, being charged $13,000 a month on it's because I vibe coded my app. I don't know how to
Yeah, yeah.
actually do this, blah blah blah. It's incredible. So we'll catch the silly stuff that AI just decides to throw in. But also, honestly, let's just even take AI out of the picture. It's like even a developer just writing its own stuff, everybody makes mistakes sometimes. So it's like,
Oh
oops,
yeah. I'm good. Cool, cool, cool.
we'll catch that stuff too.
Mhm.
Code is code. Like code is code. It's gonna do stuff. Whether an AI wrote it, human wrote it, they did it together. We will be able to catch this kind of stuff. Um, let's look at some SaaS. Everybody's favorite juice shop.
Yeah.
Um, so obviously we're gonna find, and let me ungroup these. Obviously, we'll find what you expect, right? SQL
Yeah.
injection, all that kind of stuff.
Hmm.
We'll go into kind of the things that we're looking at and everything.
Yeah.
But the things that you typically need like a runtime for, a DAS for, like this business logic stuff,
Mhm.
we're able to find this kind of information, right? So I'm going to do business logic errors. Okay.
Look at that. Oh,
So what's different here? There's a few things that's different here. Obviously, we're going to give you the source to sync. We're going to give you the whole data flow, all this good information, right? What this is, what the finding is, the attack vector table, the entry point, control, impact, This
Hmm.
is really good information, very, very useful information, security controls, what's missing, what's weak, all of that good stuff.
Yeah.
The thing that I like the most, I think, is this verification scorecard, meaning this is part of our kind of false positive reduction,
Yeah.
where we grab a finding and we're going to look at these different flows and these different things, these different characteristics of the vulnerability to confirm if it's a true positive or not. And
Hmm.
this is a huge part of it where we're actually giving the context and the actual proof or the actual information of is this a true positive or not, or is this a false positive? So it's like, does a dangerous sink exist? Yes, it exists, and here's the evidence for that. Is the sources attacker controlled? Right? Yes, here's the evidence. Data flow is complete. Yes, here's the evidence. No effective sanitization. You haven't sanitized your input. Yes, it's this is confirmed, and here's the evidence for that. It's reachable in production. Yes, and here's the evidence that it's reachable in production. You have not excluded certain code. Yes, here's the evidence that it is confirmed. We're classifying this as a true positive because of all this information.
Yeah.
So this is part of our false positive reduction to
Mhm.
verify this
Yeah.
finding and to say like, yeah, this is actually bad kind of thing. And again, we follow the severity scoring, the attack vector, the value, all this lot of information here, right? A lot of
Mhm.
information here. What is this error, right? It's a business logic error. What does it actually do? If I'm a developer and if I'm assigned to review this, or I have to review this as part of a pull request, whatever have you, I'm in Endor, I can do this here, I can really do it anywhere. Thing I've been doing a lot lately is like, hey, you know what? Uh, explain this finding to me in layman's terms. I like doing this because I'm like, I just need to know for real quick, what is this actual finding? And what it does is, in simple terms, the problem is that any logged in user can upgrade not just their own account, but also others' users' accounts to a deluxe membership by specifying the other user's ID in the upgrade request. So, like all willy nilly, I can say, I'm going to upgrade myself to the pro tier, deluxe tier, right? I'm going to upgrade Robert to the pro tier, deluxe tier. And again, this isn't something SaaS can do, this kind of
Yeah.
logic to
I
say,
mean, this
yeah,
businesses have built entire, or people have built entire businesses on doing things like spotting indirect, insecure direct object reference flaws in APIs.
yeah,
Like I've worked for a company whose most main business was that, and so
yeah,
here we have a tool that does it really nicely as part of your SaaS and gives you the and shows you're working. Yeah, I found this thing. This is all the details. This is why I think it's a problem. It's fantastic.
yeah. It's this is the kind of stuff like
And it,
the
and it, and
blog.
it
Oh
passes
yeah,
back information in such a way that someone can
yeah,
fix the problem easy, or something can fix the problem easy, which is,
exactly.
you know,
Exactly. And like you can kind of see where we're going with this
yeah,
with remediation that's coming
mm,
soon, where you'll be able to open a pull request with the fix in it based off of all this super valuable data for it.
yeah. And
Um,
it's nice because we know that we've got tools out there that people are using that can implement fixes, so we don't
yeah.
have to worry about trying to build an AI to mess with people's code
Hmm.
interactively for them. But we do know that we can pass back
Hmm.
the kind of context that they will need to resolve it using the tool of their choice.
I pulled up
Okay,
the questions because I've been talking a lot.
yeah, I was going to say, well, actually, the joy. I'm gonna. If you stop sharing, I'll flip back to my cool
Yeah.
questions screen. He says, hopefully. Let's just share
Yeah.
and see if I can share my question there. Share the right thing. Right, it says hand says questions. So the good thing about you doing all the talking is that actually we've had a bunch of questions come in talking about token use and what are the different interfaces and is there a kind of like business logic and so on and so forth. So we've actually answered those as we've gone through. One of the questions that's come up a couple of times that we should definitely address, and I'll put in the Q&A answer our link to our sort of like our trust and compliance information from our docs.
Ah,
But it's like, okay, so this sounds good, but what are you doing with my code? Where's my code going? The exact question was from Nikolai. Hello, I have concerns regarding the code-based security. Are the prompts stored on your end? But I think if you could just
no,
2 minute, the 2 minute, like, what are you doing with my code, you evil sneak
no.
people?
So here's what we do. When it comes to SaaS, especially, we will segment the code. So we're not storing your actual code,
Hmm.
right? And anything that we do, let's say for agentless scans being through the GitHub app integration, right? For SCA, for example, we clone the code so that we can build out the application, run it, run a scan, provide the results, delete the code, right? So we
Yeah.
never store code. Every analysis can be done on your side, meaning if you want to, no code can leave your premise. We have an outpost model where literally everything sits behind your firewall. We just get back the scan results and metadata, right? When it comes to the LLM stuff, we use Gemini and Azure, OpenAI, as our models of choice right now. We will have bring your own key soon for that. We
Okay.
don't store the prompts. We don't
Mhm.
train our own model. We don't use your data for training. None of that. We don't do any of that. There's another link, Robert. I think I'll send it in the chat of like how we handle data. Um, how we handle data, where it specifically goes through. It's in our docs. It specifically goes through handle data.
And if we don't find it now, we'll make sure that the
Yeah, we'll
full
send it. We'll
information
follow up.
comes in as well.
But it's in our documentation, and we can send it. It specifically goes through like what we actually
Yeah. Well,
do.
which commands? Yeah, I have seen that
Yeah,
one as well. So we'll make sure that goes up here. But
that's
that,
a
I mean,
good.
that's an increasingly important question that everyone should be
Yeah.
asking. So thanks for that, bringing that up, Nikolai. I think we've covered every other question just with your excellent narrative. I'm just seeing if there's
Let's
any.
see.
There's one. What interface is best? Was kind of like a question. I think that somebody had, and I also have as well. But I'm not sure if there's a right answer to that. But I'll give you that as our closing question. If I said to you, we've got this MCP server, we've got skills and this stuff. What would you say?
Ah,
Does it even matter?
I have strong opinions on some of this stuff. Here's what I think. I think everything has its place. Okay. I like personally skills and hooks when I'm in using Claude Code. I like MCP and skills and hooks when I'm using IDE or like a Devon or something like that.
Hmm.
I think MCP skills and hooks in something like a Devon or like a Copilot within GitHub and those more like agentic operationalization type of agents, those three put together is gold, in my opinion.
Yeah.
I think in Claude Code, I like skills and hooks. Like
Yeah.
MCP can be fine and it can be useful once in a while. But just personally, I've seen it be skills and hooks are really, really nice there. This is kind of like what's your favorite restaurant to eat at? Like,
Hmm.
what do you like to order at the Outback Steakhouse? I like the steak. I'm very meat and potatoes guy. I like the steak and I like my fries. My kids like their chicken tenders. And my wife hates all that. She wants the salmon. It's really like just what you like and
Yeah.
what you prefer, and what you're doing and what you're using it for. There were a few questions here that I can answer super quickly.
Okay.
Is AURI model agnostic tool? Is it more cost effective than Cloud Code? Yep, I answered that. We use OpenAI and we use Gemini. Um,
Oh yeah.
we found that as we tested them all. We found those as the most cost effective with the best results in relation to being the most cost effective. And we can actually tweak it to make the results even better. Not the model itself, but our prompts. Does AURI work with Bitbucket? Yes, doesn't matter. Doesn't matter to us.
Yeah.
What about POC exploit generation? Not yet. That's coming soon with the remediation. We'll
Interesting.
be able to show the exploit and we'll be able to actually show that information as well.
And so you've got to prove afterwards that you fixed it or that your
Right.
little friends fixed it.
Right.
Excellent.
And the beforehand, like, hey, this is how it gets exploited kind of thing. So
Really
both
useful.
ways.
Fantastic. Well, I think all that's left to do is to thank Amy for being our producer in the back end and keeping us on track. Matt, thanks for the fantastic demo, and most of all, thanks to all the people that have turned up and asked questions and provided us a chance to talk. Whether you're listening to this live today or you're watching this later on, we'll issue follow-up information to all the attendees. And hopefully we'll see you again on another webinar where you'll get to listen to some more people talking about things that are interesting to you. And if you have like the things you'd like us to see us discuss, then there'll be an opportunity to feedback. You can always catch us where various email addresses, or I think we're probably both on LinkedIn and various other. We should put our social handles up next time, or open a GitHub issue or something. But yeah, thanks very much, everyone, and hope to see you again soon.
Thank you all.